Hi, welcome back. And today we are going to discuss about flowchart of Newton-Raphson method. So here we are going to implement the design thinking approach in the flowchart of Newton-Raphson method. So in the empathy stage, we are having a lot of confusions how to solve the complex problem. We are having the multiple iterative steps. So where and when which iteration we are getting the accurate result and how to form the Jacobian matrix, and we have to calculate the each element from the Jacobian matrix. So what is the convergence criteria? Why it is important? So how this can be used in the large scale system? Can you able to visualize the representation? So like that, we are having the n number of questions in the empathy stage. And in the defense stage, so we have to understand the each block in the Newton-Raphson flowchart and its purposes. So and also they follow the decision point loops iteration condition systematically. So this can be used to apply in the power system to solve the load flow solution for the transmission system, and we have to analyze and we have to compare with the convergence whether it's acceptable or not acceptable. So this is the major objective in the defense stage. So in the ideal stage, in the flowchart component, so initially we have to start with the initial voltage. So in the Newton-Raphson method, the bus data, line data we are given. So from this bus data, line data, we have to form the bus admittance matrix. So from the bus admittance matrix, then again the second step, so we have to assume the initial voltages as 1 per unit. Once the voltage is assumed, then we have to go for the iteration index. We have to go for the first iteration. So in this first iteration, we have to calculate the change in real power and change in reactive power from reactive power. So and we have to calculate what is the mismatch, what is the change in power from the actual and change. So we can. So again, the calculated change in real power and reactive power can be compared with the convergence. So whether it's converged, yes, if it is converged, then we can go for end result. If it is not converged, again we have to go for iteration index. So we have to go for another iteration. Okay, so again, whether it's converged, yes, we have to go for n. If it is not converged, again we have to go for another iteration like that. So from this, we have to form the Jacobian matrix. If it is having two buses, we can form two cluster matrix. So it is nothing but a partial derivative of power and that is the partial derivative of real power and reactive power with respect to the voltage and the phase angle. So again, from this Jacobian matrix, the elements of Jacobian matrix, we have to solve the mismatch equation. So here we have to determine the change in phase angle and change in voltage. Once it is obtained, and we have to update the angle and voltage, and again we have to recalculate the change in power and change in real power and reactive power. So this is the main objective, and this is the flowchart of Newton-Raphson method. So here the main algorithm, we have to read the system like bus data, line data and initial voltages we have to assume except slack bus, and we have to compute the bus admittance matrix. That is, we have to build the from the with respect to the line parameter or line surging admittance etc. And we have to go for the iterative loop for first iteration, second iteration like that, and we have to calculate the mismatch and we have to form the Jacobian matrix and we have to solve the data and we have to update the data. So once the convergence is done, we have to display the result. Otherwise, again, we have to go for the another iterations. So here in this stage, the convergence test, iteration limit and bus step for the different conditions. Okay. So here, this is the condition for the convergence. If the maximum change in power, maximum change in real power and reactive power, which is less than the convergence, if yes, we can stop and display the actual result. If it is no, we have to continue for the Jacobian matrix. And according to the iteration limit, what is the condition? If the number of iteration we are this is a maximum iteration, this is current iteration. If current iteration is less than the maximum iteration, we have to go for the next iteration. If it is no, we have to stop and solution is not converging. On the bus type check, we have to check the peak whether it's slack bus, whether it's PQ bus or whether it's PV bus, like that. So the action, it include appropriate equation, the Jacobian matrix. So based on the condition check, we have to form the Jacobian matrix. So in the prototype, this is a simplified process of prototype. We have to start. We have to gather the input data, we have to set the bus voltages, and we have to calculate the change in power, change in real power, reactive power, and we have to check for the convergence, we have to form the Jacobian matrix, and we have to update the result, and we can be able to display the results. So this is the numerical data which are given for an sample 3 bus system. So the bus 1 voltage is 1.05 per unit. This can be taken as the reference bus, and bus 2 is PV bus. The P2 is nothing but 0.5 per unit, and V2 is nothing but assumed as 1 per unit. And for bus 3 PQ bus, P3 value is minus 0.8 per unit, and Q3 is minus 0.4 per unit. So from this tolerance value, we can able to go for the number of iterations, the maximum change in power and maximum change in real power and reactive power. Okay, so we can able to go for the nth iterations. So these are the real-time applications. It can be used to solve the load flow analysis, and can able to integrate the renewable energy with the smart grid, and the smart grid operation can be monitored by using the PLC and SCADA system, and it can be used to analyze the contingency in the power system. So this is the mind map. So we are gathering the input, and we have to follow the algorithm, the convergence, the output, and the application and advantages. So this is the curative challenge. Why does Newton-Raphson converge quadratically? And what happens if initial guesses are far from solutions? So if you know the answer, just you can put in the comment section. So this is another assessment. Here, draw the complete flowchart for Newton-Raphson load flow analysis. Clearly more called the description. This is one assessment, and another one is nothing but and one problem will be given. So you have to solve the step by step, and finally you will get the answers. And these are the few references for this topic. Thank you.